In this video, we'll take a look at notes in section 9.2, components of vectors. So two vectors, when added together, have a resultant equal to the original vector, are called components of the original vector. If you recall in section 9.1, when we added two vectors together, A and B, you could do a parallelogram method. The resultant is the result, or the diagonal of that parallelogram, is the result of adding A plus B. A and B are called the components of the original vector R. So in this section, certain components of a vector are of particular importance. If the initial point of a vector is placed at the origin of a rectangular coordinate system, and the direction is given by an angle in standard position, we can find its x and y components. These components are vectors directed along the axes that, when added together, equal the given vector. The initial points of these components are at the origin, and the terminal points are at the points where perpendicular lines from the terminal point of the given vector cross each of the axes. Finding these component vectors is called resolving the vector into its components. So it's easier to see what we're talking about if we take a look at a diagram. So below we have to find the x and y components of the vector A, shown in the figure. The magnitude of A is 7.25. So the magnitude of this green vector A is 7.25. Notice it's placed at 0, 0 along the x-axis, and it's a direction of 62 degrees measured in standard measurements. So the angle measured, the direction, is 62 degrees, and the length of the vector, capital R, or capital A in this case, is the length of the vector, is 7.25. So what we want to find are the two vectors so that when we would add them together, they equal this vector. So notice they're along the x-axis and along the y-axis. If we draw a right triangle in here, then this side length is the y component, the bottom is the x component. So to find the x component, use the angle and use right triangle trigonometry. So to find a sub x, we would take, let's see, the 62 degrees, we have the side adjacent and the hypotenuse. We would take the cosine of 62 degrees is equal to a sub x divided by the hypotenuse of 7.25. Multiply both sides by 7.25. A sub x is equal to 7.25 times the cosine of 62 degrees. And we'll type that in the calculator in a minute. So to find the y component, notice it's also a side in the triangle. It's the side opposite the 62 degree angle. The trig function that uses opposite in hypotenuse is sine. So the sine of 62 degrees would equal the y component divided by 7.25. Multiply both sides by 7.25. The y component is 7.25 times the sine of 62 degrees. So let me open the calculator and we'll go ahead and see what those are. And then notice, let me get the calculator over here, we go. All right, so we're going to make sure that your mode is in degrees. We take 7.25 times the cosine 62 degrees, and we end up with about 3.4. So the x component is about 3.4. That means that's the length of this vector along the x-axis. That also means if you were to look at the terminal point, 3.4 would be the x-coordinate of the terminal point. Now we find the y component, take 7.25 times the sine of 62 degrees, and we end up with about 6.4. So the y component is about 6.4. So notice that would be the length of the vector along the y-axis. It's also the y-coordinate of the endpoint. So we can generalize this without having to draw a right triangle every time. So if we're going to find the x component, we're always going to take the magnitude of vector A times the cosine of the angle that it makes in standard position. To find the y component, we're going to take the length of the vector, magnitude, times the sine of the angle in standard position. So you can still draw right triangles, and that's where this comes from, but now we can use that property to find the components of a vector at any location around the coordinate plane. So our next problem, a surveyor's marker is located 14.4 meters from the set pin at 126 degrees standard position angle as shown in the figure. Find the x and y components of the displacement of the marker from the pin. So we have an angle of 126 degrees from standard position. So the green vector has a length or a magnitude of 14.4 meters. Let me draw that on there. And what we want to find is the x component and the y component. So those are the two vectors that we add together to get the third vector. They also happen to be, if you draw a perpendicular, the two sides of a right triangle, and 14.4 is the hypotenuse. So we're using d sub x and d sub y. So to find d sub x, we take the vector length d times the cosine of the angle. To find the y component, d sub y, we take d times the sine of the angle. So for our x component, we're going to take 14.4 times the cosine of 126 degrees. And for our y component, we take 14.4 times the sine of 126 degrees. So 14.4 times the cosine of 126 is negative 8.46 if we round to two places. Notice that makes sense. It's in the second quadrant, so your x-coordinate is negative. And since we're in the second quadrant, the y-coordinate should be positive. So we take 14.4 times the sine of 126 degrees and end up with about 11.65. So those are our two vector components, x component, y component, negative, positive, and they end up being in the third quadrant. All right, last example is one from homework. Resolve the given vector into its x component and y component. The given angle is measured counterclockwise from the positive x-axis in standard position. So I'll go ahead and draw a picture. Magnitude is 2.34, and our angle is 247.41 degrees. So that's going to be in the third quadrant because it's between 180 and 270 degrees. So it's somewhere in here. The vector itself is 2.34 magnitude, and the angle in standard position is 247.41 degrees. And what we're trying to find are the x and y components. So we're trying to find the horizontal vector, a sub x, and the vertical vector, a sub y, so that when you add those two together, you end up with the vector that we're given. So use the formula. A sub x is the length of vector A times the cosine of the angle. The y component is the length of vector A times the sine of the angle. Substitute our values in. 2.34 is the magnitude times the cosine of 247.41 degrees. For the y component, we take 2.34 times the sine of 247.41 degrees. And notice our vector is in the third quadrant, so our x component and y components should both end up being negative. So we have 2.34 times the cosine of 247.41. And I'll type in the other one as well, 2.34 times the sine of 247.41. So our x component ends up, we want to round to the nearest hundredth. So our x component ends up being negative 0.89 rounded to the nearest hundredth is negative 0.90. And our y component is a negative 2.16. And notice they're both negative, and if you take a look at where the vector ends, this length of vector x, the component, would be negative 0.9. The length of vector y would be negative 2.16.